Now that we've identified all the easy information associated with the y-intercepts, let's identify easy information associated with factored form and with vertex form. Let's start with factored form. I think that most of us remember some of the easy things that we're looking to identify from factored form here. If we look at our first example, our question that we would want to ask is, what's the simplest piece of information you can tell me about this quadratic based on the fact that we're in factored form? Well, the thing that we like factored form for is the fact that the zero product property applies. I know that if I am looking for the roots or the x-intercepts of any equation, I simply have to set y equal to 0. We've seen the zero product property informs us that if any two numbers multiply together to give us 0, then it must be the case that either the first number is 0 or the second number is 0. This leads us to two different equations. X minus 3 equals 0 and x plus 5 equals 0. We can solve each of these equations then to identify the two locations at which we hit the x-axis. Here we can see that x equals 3 is our first root, and that x equals negative 5 is our second root. Pretty typically in this case, we don't show this line of work. It's usually very easy for us to recognize from this factor that positive 3 would cause this group to go to 0. 3 minus 3 is 0. It's pretty easy to see from our second group that negative 5 would cause this group to 0. Negative 5 plus positive 5 is going to give us 0. So pretty typically, we go directly from this line to stating our answers. I've given a second example over here to remind us that we can't simply just grab the opposite sign number that we see on the inside here. Negative 3 gave us positive 3. Positive 5 gave us negative 5. We want to be a little bit more careful about that. Remember that sometimes in factored form we actually have coefficients on the x within each of our groupings here. So what I'd like us to recognize here is that here we are in factored form. I have three different factor groupings that I'm interested in here. And I'm wanting to ask myself the same question as we asked before. If we were to let y be equal to 0, then what value of x will cause each of my individual groups to go to 0? Well, the first and trivial question that I can ask myself is, on what circumstances is negative 1/4 the same number as 0? Well, negative 1/4 is never 0, so it turns out that we don't get any root information from negative 1/4. We can then ask our next question, what value of x causes 2x plus 1 to be 0? Well, this one can actually happen. We can go ahead and solve this guy here. We're asking what value of x causes 2x plus 1 to be 0, so I can solve this equation. And we see here that negative 1/2 is our first root associated with this equation here. Negative 1/2 is a value of x that causes this term to be 0. 0 times anything will always give us 0. That's what makes this a root. Very similarly on the other side, 3x minus 7, we would also be interested in knowing what value of x causes this to be 0. Again, we can solve. And we see here that 7/3 is the other root associated with this equation here. If we plug in 7/3 for x, the second group will be 0. 0 times anything will give us 0. That's what makes this a root. So what's our last really easy piece of information that we can get from quadratics in certain formats? Hopefully it's not a huge surprise to you that it's pretty easy for us to identify the vertex when we are in vertex form. In general, vertex form is given as y equals a times x minus h squared plus k. What we've previously identified here is that the vertex location is at hk. The only thing we really got to make sure that we remember about vertex and vertex form is watching out for our signs. Notice here that the negative is built into the formula, whereas here we have a positive in front of the k. H and k, if in exactly this form, are going to give us our vertex locations. In our next example then, 2 times x minus 3 squared plus 4, we can see that this is in exactly the same format with the signs all matching. These are still negative, these are still positive right here. So it looks to me that the vertex location for this is going to be at the location of 3, 4, because that is our h and k terms. In our last example here, we can see the opposite scenario for both terms. Here we have an x plus 7. Notice that it's possible for me to think of this as x minus negative 7 squared. And in this case, this now looks to me like x minus h, where h takes on the value of negative 7, not positive 7. Negative 7 for h. Very, very similarly, on the end out here, I can also think of this as plus a negative 11 out there on the end. In this case, again, I'm forcing myself to match the original format here with adding a number. What number am I adding? Negative 11. So it looks like in this case for us here, negative 7, negative 11 is going to be the location of our vertex. So just remember to keep an eye on your signs whenever you're looking to read the vertex information off of a quadratic that's in vertex form. So, aside from our easy column of the y-intercepts, we've now also seen that the easy information that we can always obtain from factored form is the roots. If ever we're in the format of x minus r times x minus s, we will always have roots located at x equals r and s. Remember that the negatives are built into the formula here. We always end up with the opposite signs here. We're always asking ourselves, what number could I plug in for x to cause this value to go to 0? In vertex form, hopefully, unsurprisingly, we see that the easy piece of information to identify is the vertex location, which is always located at hk. This is sometimes referred to as hk form. And again, remember that there is a negative built into the formula associated with the x term. There is not a negative built in with the y term. What this means is that every time you're reading off the vertex location from vertex form, you'll always have the opposite sign that you see within the parentheses, but you'll always have the same sign that you see outside of the parentheses. Now that we've seen how to find roots in factored form and the vertex in vertex form, let's do a few practice problems and confirm our answers in Desmos. First, I'd like you to identify the roots of these first two equations that are both in factored form. You should notice that the first is certainly a quadratic. As we're multiplying two x's together, we should get an x squared term. You should certainly notice that the next example here is not a quadratic. Here we're multiplying a total of 4 x's together. We should get something with an x to the 4th in it. That's not going to be quadratic, but it is going to still be a polynomial equation. It's going to have a lot to do with the quadratics that we're looking at here. Next week in class, we're going to talk all about higher order polynomials. And the good news is things like identifying the roots work exactly the same way as they do for quadratics. Quadratics are just a second order polynomial. So you should still be able to identify the roots here in the same way that we've seen how in the previous video. You should still be able to confirm that those are your x-intercepts when you go to graph in Desmos. Again, down here, you're going to go ahead and find a vertex. Remember that our biggest concern here is just to watch out for the signs, making sure you're getting the right positives, negatives here. So go ahead and identify where you think the vertex is located for this guy here, graph it in Desmos, and see if you're getting the right answer.